Logistic and exponential growth are very similar. However, the exponential growth has no cap to it, it just continues growing, where logistic growth has a carrying capacity which balances it out. These are shown through the equations that are given on your biology equation sheet, where the one on the right has K, which is the carrying capacity, and the one on the left does not. So the one on the left is exponential and the one on the right is logistic. And they're represented by this graph, which shows that the one on the right will balance itself out and is the more reasonable in an environmental situation. The first thing I'm going to do is explain the variables of both equations. Delta n is the change in population size, delta t is a change in time, and delta n over delta t is the thing you're trying to solve for. R max is the maximum per capita growth rate of population, n is the population size, and k is the carrying capacity of this population. The next thing we're going to do is an example of an exponential growth problem. It's a population of 50 rabbits recently found in an uninhabited field are experiencing an exponential growth, and their growth rate is 0.12. What is their population size after 1 year? If you want to solve this without my help, then you can pause the video here, but otherwise we'll continue on to explain how to solve this. The two key parts of this problem are the fact that there are 50 rabbits and that the growth rate is 0.12. If you plug both these into the equation, you get 0.12 times 50, and then if you multiply those together, you get a growth rate of 6 per year, or 50 plus 6 equals 56 overall in the growth of that year. Next is an example of logistic growth. It is the same rabbits as before, but the field, it turns out, wasn't uninhabited. It turns out there's already rabbits living there, so this means that only a certain number more rabbits can be supported. So this means they're actually experiencing logistic growth, which has a carrying capacity of 60. And this means with the same growth rate, their population size after 1 year would be solved for by multiplying the 0.12 times the 50 times 60 minus 50 over 60, which is the carrying capacity part of this. And that ends up resulting in 1 instead of 6. So instead of being 56 rabbits, is now 51, which means that it will cap out at around 60. This is now just a quick example of what happens in exponential growth versus what happens in logistic growth. It has just reached its carrying capacity, which means that it will now not grow much bigger in size, and it will just change in population.